Well, hello, everyone. Thank you for joining us this evening. I am Joel Kaufman. I am substituting for Tom Longstaff, who is the chair for Computer Science, Information Systems Engineering, and Cybersecurity. He recently appointed me the Deputy Program Manager, which means I shadow Eleanor Clan, who's in the back of the room, and get to do all of the tasks that she delegates to me, including the introductions this evening. So it is with great pleasure that I can introduce Scott this evening. He's been doing software development for 30 years or so, using a variety of different languages. And so he's going to speak to us tonight about domain-specific languages and code generation, as you can see from the title slides. By day, he works at the Applied Physics Lab, and he also teaches in the Whiting School of Engineering. He's taught a number of different courses for the EP program over the years. Currently, he teaches Android development. So please welcome Scott this evening.
Thank you. Okay, so let's just dive right on in here. I've set up some slides, just a really brief slide presentation. Most of this will be code talk. So first of all, let's talk a little bit about what happens when you want to enter data into a program. Programmers have it easy on the data entry, right? Because we know how to code. We can write code that has the data inside of it. We can set up a binary file with the data. We can use comma-separated values. We can use XML, which is human readable. Yeah, right. We can use JSON, which is a little more human readable, but still not all that much. Non-programmers or subject matter experts, on the other hand, have it a little bit more difficult. A lot of our non-programmers or a lot of subject matter experts are not programmers. And what ends up happening is when they want to give us data, sometimes they'll give it us in one format and then we have to convert it to another format. Or we say, hey, just write this XML for us. And what ends up happening? It doesn't work all that well. I mean, XML, JSON, CSV, things like that, it's really easy to get the syntax wrong. And it doesn't feel that natural to them. So they generally say ew when they see that and have a little bit of difficulty. So sometimes what we'll do is we'll have them enter data in Excel using a spreadsheet, and we can save it off as a CSV and then import it. And that's not too bad, but it's still kind of a workaround for the situation. We'd like to try to make their job a little more easy. One of the things that comes up a lot when you use things like spreadsheets are bad characters. Note those curly quotes that show up in PowerPoint here. Those give people a lot of grief, especially if you're trying to ingest something using ASCII as opposed to UTF, or you forget to check for those UTF characters. You end up getting some garbage in your program. So sometimes you'll send them XML and JSON. Again, they do ew with that. Very easy to make syntax mistakes. So we can enhance this process a little bit by creating something called a domain-specific language. And a DSL is something that's just a little language that you've written. You can determine the syntax you want. You can use the words that are familiar to the subject matter experts. You can try to make it look like documents that they've worked with so that their editing these feels more natural. A lot of times this will end up creating less code work for you because you want to have code that creates your data. Sometimes you have more code depending on how you're actually doing your DSL. It can make their data entry more terse. I mean, especially compared to something like XML, which is just this huge verbose mess. It's very specific, or can be very specific to the task that they're working on. So if they're doing some kind of math task, they can use this. If they're doing chemistry, if they're doing data entry about disease surveillance or something like that, all of the terms and everything can be very specific to the task. And even more so, if you had data entry for a specific type of disease entry, you can tailor it even more to that specific disease. You can also add some validation. XML, the validation is pretty weak on that. You don't have a lot of cross-field validation without a whole lot of extra work. In a DSL, you can have it set up an IDE for you automatically and use that to do some cross-checking. Here's a couple examples of what are called internal DSL. This is kind of a simple version of a DSL that you actually do inside of a programming language. So if we look at something like Java, sometimes you use something that people refer to as a fluent API. So it looks like it reads kind of like a sentence. So in this case, you might say, new robot, turn left, move, and shoot. This makes it feel a little bit more like a sentence and might be more approachable to somebody who's not a programmer. But it's still code. It's still easy to forget the dots, the semicolons, put a paren in the wrong place, things like that. You can have a little bit nicer DSL that's inside a language in something like Groovy. There's some languages that make it a little bit easier to generate something. And you can see this is quite a bit more readable, and that's actually Groovy code. So we've designed some support inside Groovy to make that look a little bit more natural. But it still has some syntax issues. It still has some grooviness around it. External DSLs, on the other hand, are ones that are completely separate from the programming language. You edit it in a file, the programming language reads it in and parses it, and then does something with it. This is an example from a tool called GraphViz. Has anybody ever used GraphViz? If you haven't, it's a fantastic little tool for drawing graphs. It'll do things automatically. This particular example here generates this little graph down here in the bottom. So if you want to just create a really quick little directed graph or undirected graph, you can use something like this, and it's very easy to set up. A little bit more complex example, but more to a specific task, is a custom DSL that I'm going to show you for this little adventure game. And we'll see here that this is defining the data that somebody who's a subject matter expert, in this case the person who's writing the story, can come in and say what types of items they have, what types of rooms they have, how the rooms connect with different exits and things like that. And it becomes much more readable. And in fact, this will create an IDE for us, which will give them content assist so they can hit Control Space to figure out, well, what can I type at this point? Some things are actually cross-linked. So when you get down to here where it says contains key, you can hit Control Space and it'll give you a list of the current objects. And you get that all for free. It's really neat. So the examples we're going to go over today, first of all, this little text adventure game. And in this text adventure game, I have two domain-specific languages that I'm using here. One is for commands. Now, in a text adventure, how many people here have played a text adventure game before? The older folks in the room, right? 80s, yeah. I used to play these all the time, and I loved them. And you have a set of commands like go north, get key, unlock chest, things like that, that you can type in, and you're communicating with the game to advance a story. We're going to have a little command parser that allows you to recognize those commands. And it's a very, very simple command parser. I'm not doing anything spectacular here. Then I'm also going to have a second DSL for pulling data in. I'm going to show you a couple of versions of this that first of all have the data inside the program and then move it outside. And then we'll get to the DSL just so you can kind of see the difference in how these things look. We're going to use Antler for the command parsing here. Antler is a parser generator. It's been around for quite a while. I actually worked on it a while back. And what we're going to use it for is just to match the input and run a command. If that's all you need to do, Antler is a fantastic tool for you. If you're trying to write something like a compiler, Antler can work as a great tool for you as well. If you want something that's a little bit more friendly to generate a parser or generate an IDE for your language, Xtext is a better choice. Xtext uses Antler behind the scenes, and in this particular example, we're going to use it to build model classes. So it's going to describe what that entry looks like, building Java classes to represent each of the items in that model. It's going to generate a full IDE for you inside Eclipse. And there also is support, by the way, for using IntelliJ, although it's not quite completely baked. They're having a little trouble getting people to work on it right now because IntelliJ sucks. We're also going to use it to read that model instance in at runtime so that you can create your code, have it sit on one spot, and then create this entirely separate model and run different models with the same piece of code without having to modify the code at all. Our other example is going to be for object model generation. So this is pretty much for any type of code that you want to write. You can use this to generate your model. And I'm going to have a single DSL for this using Xtext. Xtext is going to generate those model classes and an IDE for us. And so this will make it so that if you have, let's say a bunch of model classes with getters and setters, maybe they're going to fire events when things change. Maybe you want to set it up a builder for it or a factory. You can have it generate code for you automatically. So let's just dive right in and take a look at some of this stuff. Let's first of all take a look at some of the data in the game. This is an initial version of this project for the game, just sticking data inside of our game class. How's that font size? That's kind of microscopic, isn't it? Let's fix that up here. So basic text font. Let's edit him. How's that better? Now it's huge. Okay, so here's what our data looks like to start with. We're just creating instances of objects, putting data inside the fields there. I have my command parser in Antler, And this is what's called an ANTLR grammar. We describe what a command looks like, and a command is the word get, a literal word get, followed by some word. It could also be followed by from some other word. So you could like get key from safe, or get letter from safe, something like that. Examine something, drop something, look something, or look just in general, inventory, open, go, west, east, north, south, and so on. So we're just describing what a command looks like in this language. And this is a very overly simple grammar here. We'll see down here we're describing what a word is. It's a letter followed by 0 or more letters. A fragment that could have been represented as letter plus, by the way. I'm not sure why I wrote it that way. A letter is A to Z or A to Z in uppercase. And then white space is automatically skipped by the parser. So I have a plugin in Eclipse right now that takes this command grammar and generates code for it. So there's two things here called a lexer and a parser. And it generates a bunch of lexer code for us here. Think of the lexer as recognizing letters. You know, what do you do when you read a book? When you look at a book, you see a collection of letters and spaces, right? And your brain is going to take the letters, understand what those letters are, combine them into a word, throw away all the white space because you don't care, and then look at the series of words and figure out what it means. That's exactly what the lexer and the parser are doing. The lexer takes your letters, and recognizes those letters, making words out of them, and the parser takes the words and figures out what the semantics of those are, what it means when you actually parse those. So it generates code for that lexer and the parser for us that we can use in our game. And let's see, where did I put that in here? I guess I did not have that in the game part. I thought that's where it was. Must be in the UE. Yeah, there we go. There he is. So here's what the code looks like to actually use that generated grammar. We're going to take the command that the user typed in, make a stream out of it, pass it into the lexer. You get a set of tokens out. Those are the words. Pass it into the parser, and then we're going to run the command rule inside that parser, which is this guy right here. That will say, when I say get word from something, I'm going to run this method inside the game. So it gives us a nice way to match and run something. That's all we're going to use ANTLR for in this particular case. The rest of this, let me just go ahead and run this just so you can see what the game looks like. It's a very simple little game. Hey, it's microscopic. I should have bumped that font size up there. So it says command, look, this is the front porch of your house. You can go north. And if I type in go north, this is the main hall of your house. You can go south, north, east, west. I'm going to go east. And then here I see a key, so I'm going to say get key. I'm going to go back to the west, go north from there. You can see I've played this before. And this is my study. It's where I pretend to work. I see a safe, so I can say unlock safe, open safe, examine safe, and it says the safe contains a letter. So I can say get letter from safe. I got the letter, examine letter. It reads you win. Boom, I'm done. So real simple little text adventure game there. That's just the mechanics of how this thing works. The data to start with is in code. I don't like that. My writer is going to have a really hard time with this, entering their data. So I want to make it a little bit better. And one thing that I could do to make it a little bit more readable is to use a Fluent API. So if I take a look here, now what I'm doing is I've changed my classes a little bit so that I can say model.add, passing in an item, .setName, .description, .carryable. Notice the difference here, item, setName, .description, .carryable, versus this one here, where I say item, key, it's a shiny brass key, true. What's the problem with this right here?
The user already knows the syntax to use for that.
You have to assume the user knows the syntax. In this particular case, the order of arguments. I mean, what if I had 10 different strings in a row? I mean, how do I know which one's which? It's easy to confuse them. In this other version here, where I can chain these together, I create the item using a default constructor, and then just have setters that describe exactly what you're setting. So it's a much, much friendlier thing for you as a programmer and for a user. But this still is code. So it's not going to be a great, can somebody grab the door there? But it's not going to be a great way to get them to enter data for you. Just to show you what the difference in the model on this one is, all I did on these was for each of my setters, I just returned the item, the actual item type. And so I say return this. So every one of these setters, or anything that modifies it, returns this. And then you can just chain them together by saying ... and so on. And it gives you a fluent way to read the setup here. Now I have another little problem here, order of instantiation. Some of these things, you'll see like the safe here has a letter inside of it. So letter has to have been defined before the safe, right? So up here you see I define the letter. It just so happens that none of my items have any type of circular dependency. So I can do this, that works. But when you look at the rooms, and you're setting these rooms up, let's see. So we're adding these new rooms. The rooms are going to have circular dependencies. You can go east from one to get to the other, and then go west to go back. So I can't add the exits at the same time I'm setting up the rooms. So I have to set up some variables for them, and then later on, add the exits. I have to make sure that they're set up first, and then actually connect them. That's a problem that I'd like to solve at some point. This is a version here I just want to show you real quick. Sometimes with a Fluent API, it's nice to get rid of the sets in those so that you just say name, description, carryable. It becomes a little bit more readable. It's not quite as standard as using getters and setters, but it makes you a much more readable API. So now let's move the data outside. And what I'm doing in here is I created a JSON file. This is one of those ones that the writer is going to go, ew. He's going to look at this. Very, very, very easy to have a syntax error in this. Not quite as easy to have a syntax error as XML, but still, you miss a comma somewhere and you're hosed. So now I'm going to define my key, my letter, my safe, my rooms, porch, direction north to hall, or direction north goes to the hall, direction north goes to the study, and so on. And you'll notice here I'm actually defining the data, the room connections inside the room definition. This has circular dependencies in it now, but it's completely separate data. And what that means is when I'm reading this in, I'm going to have to do a couple passes on the data to resolve it. One to read the data in, and another pass to resolve the exits and resolve the items contained in other items, that type of thing. So the code gets a little bit more complex. As we'll see down here, instead of having, this is our defined model, quite a bit bigger now. It's about 3 times the size it was. But I'm now going to parse in that JSON, find my rooms, my items, and then these 3 guys here are just to keep track of those strings that are in the JSON so that I can run a second pass and resolve them later. So I create my items, then I'm going to resolve the keys and the contents for things, create my rooms, and then resolve the exits in the room contents. So this is one way to set it up so that now the data entry is a little bit more natural. You don't have to worry about that order of definition at that point. But it's still not ideal. I'd like things to be a little bit more natural than that. So what I did is I used Xtext to create a project here, and it gives me these 3 projects, DSL, DSL IDE, and DSL UE. And the only thing I changed in here is this little adventure DSL.xtext. This is a grammar, kind of like that Antler grammar, but it's a little bit simpler. I'm not actually putting any actions. I'm just describing what the data looks like. And when I say something like model has 1 or more items, 1 or more rooms, and then a start in at the bottom of it, I'm going to say the field items inside my model is a collection of items. The field rooms is a collection of rooms. And start room is this reference to some other room. That's what little bracket means in there. This is going to create a model object with a get items and a set items inside of it so that it can add things. it's also going to set up code so that when it reads in the data, it's going to create that instance of the model object and put the data inside of it. So here's an item that says, if it says carryable, I'm going to mark the carryable Boolean true. If it says fixed, it's not going to be carryable. The name of it is some ID. The description is some string. Opens with a reference to some key, and so on. Is it locked? Is it open? Is it a container? What are the contents? Just by editing this file, and this is the only file that I edited, it allows us to have this language. It creates an IDE for us and creates some framework code here where I can add in my own validation rules and things. So here's the tricky part. These guys here form an Eclipse plugin. How do I test that? I'm already running Eclipse. So what I need to do is run a nested copy of Eclipse inside of Eclipse. So the application that I'm debugging is Eclipse itself with these plugins put inside of it. I do that by saying run as Eclipse application. Actually, let me debug as. So debug as runtime Eclipse. It's running a nested copy of Eclipse inside of Eclipse. And boom, I have a new workspace with all those plugins in place. Let's take a look at our sample adventure here. Here is, let me bump the font size up inside here as well. Boom, edit. I'm not recording this. Well, we got part of the recording there. I completely forgot to start Camtasia. Sorry about that. We're not too far into it. Okay, so here is an example of our DSL that we're going to use to describe our data in our little adventure language here. So we're describing a carryable item key. It's a shiny brass key. Carryable item letter, it reads you win. Fixed item safe, it means you can't pick it up, and so on and so on. Room hall, south goes to the porch, north goes to study, east goes to bedroom, west goes to kitchen. Now this is much more readable. And because it's an IDE, if I hit Control Space there, it gives me a list of all the possible rooms that I can put in. So the user doesn't even have to type all that. They can use Content Assist to get them there. And similar with where he says opens with, it'll give me the list of the items that I might be able to use as a key in that case. So this data entry now, when I go into my adventure code here, I now only have this game and UE because the model is now generated. I don't have all the other classes. My game class down here, here's the code I need to define that model. I'm going to be reading in that sample adventure file and saying get contents to create that model. Boom. It reads it in, parses it, and now I have a model object that I can just walk through. I can get stuff from my rooms, get stuff from my items, and so on. And then back up here at the top, read my room description. I'm setting up a little index by name so I can look them up more easily while the game's running. But that was pretty much it to read it. And when I run this guy now, we get the same exact thing we had before. So I can say go north, go east, get key, go west, go north, unlock safe, open safe, get letter from safe, examine letter. Come on. And you'll never guess what it says. You win. Okay. So now we have this little text adventure game being driven by this external DSL, which gives us some nice separation between the code and somebody who might be my writer who's filling this in. And this is kind of similar to what Infocom did. They set up a little language that they used to parse their text adventures. And the writers learned that little language, which was tailored for their use. And all the main code used that to actually do the running of the game. So nice, simple little example there. Questions on that one? Okay, onward we go. So now our next example, I'm going to go back to the outer workspace in Eclipse here to take a look at some object stuff here. Actually, I think, do I have in here? Let's look at, yeah, here we go. So let's first of all take a look at what problem we're trying to solve here. Let's say that I have a person class and an address class. So here's a simple little address with a street, get and set the street, a city, get and set the city. So just a simple Java bean, that's all it is. The person here, same type of thing. He has a name, age, is he alive or not, a list of addresses, and that's it. Now, just a note on what I'm doing here with this list of addresses. This is the mutable list. So this is the thing that's actually going to contain the data and have things added and removed. This is an unmutable list. So I'm just wrapping it with a decorator that stops any of the mutation methods from working. They actually throw exceptions. When somebody asks to get all the addresses, I'm returning the unmutable one so that they can't modify it directly. They have to call my add address and remove address methods. This allows me to have a place, if I want to, I can put in here a fire event to say the address list has changed. If I didn't do this, they could just say getaddresses.add, and I'd never know that the data changed. Okay? Unless I put my own decorator on there that listened for every single mutation method. So this is a little bit easier way to do that. So now I've got these two guys. Let's take a look at a little sample that uses them. And this is kind of similar to what I set up in that model for the adventure game. You see that I'm creating these objects, address 1, set street, set city, address 2, set street, set city, create a person, add the addresses, and then I'm just dumping the data. So if we run him, we'll see that he prints out all that information I just entered. Fairly simple, right? We can do the same kind of thing here to make this return this object so we can have a fluent API. So we'll see now my sample code looks like this. That's a little bit more readable, right? A little bit easier to enter the data. And you don't have to worry again about the positions of data going into the constructors. But I really, really don't like typing. And I really, really don't like copying and pasting. Because what happens when you copy and paste? If I copy a getter and setter, I'm going to forget to change something somewhere, right? That causes all sorts of bugs. You know, I might, instead of having the, let's go to the address. Instead of having the, you know, if I copy this get street and set street, I might change it to get city and set city, but forget to change what variable I'm changing, right? So I want to generate my code. If I can simplify this and say I have an address that has a street and a city, that's really all I care about, right? And if it generates the rest of this mess, that's going to save me a ton of work and be more consistent. It's going to make sure that everything works really well for me. So let's take a look at how we can generate some code with this. I'm going to go to my simple object DSL, which again I created a little Xtext project for it. And the first thing I did was set up a grammar form. And this grammar is very simple. He says the idea of a model is I specify a package, and I'm defining a rule that's a qualified ID. It's just id.id.id.id. So it's just a typical package name type thing. And then I have a bunch of classes and enumerations. My classes are going to be the word class followed by the name of the class, open curly, followed by some field declarations. So it kind of feels a little Java-ish, but this is intended for me, the programmer. It's not intended for somebody who's a non-programmer. It's just a way for me to save time and be more consistent in the code that I write. Field declarations are either basic, lists, or primitives. So a basic field says I'm going to be some other type, like an address, and I have a name on him. Primitive field is either string, int, or Boolean. I could have all the other primitives. I just kept it simple here. A list field is a list of some type, and then the name is here. And I added this little thing called singular on here so that I can create the add and the remove methods without the plural name. So if I added a list that I call addresses, I would say singular address, so that it's just going to have a get add address and remove address as opposed to add addresses. Just a little silly thing. Enumerations are just enum, some name, and then values. The values are ID and a string. Now, one of the things that I did with this and some code that I'm working on is I enhanced this enumeration type a little bit by having some other parameters added in. And one of the things that's cool about Java enumerations is you can have fields in the enumerations. So you can add extra data and have it generate all that for you. So once again, when I generate this grammar, it creates an IDE for me, creates the code to read this stuff in. It also creates a generator. And in the other project, we didn't use the generator. But this code generator here, I can come in and have it do whatever I want it to do. This doGenerate method gets called passing in a resource which represents that file. And then you say what you want to do with it. So what I'm going to do here is I'm going to say, look at all the contents and filter out everything that's not a model. So I'm just going to have models only. There's only one model at the root of this thing, so I don't have to worry about having more than one. For each of those, I'm going to say, find all of his classes and generate a class. Find all of his enums and generate a enum. This little language, by the way, that you're seeing here is called extend. That's with the letter X, T-E-N-D. And this is something that is built by the same people who created Xtext. It's kind of like a Java++. So they had lambdas and things like this and functional programming in this before Java 8 came out. So for generating a class, I'm going to generate a file taking the class, let's see. I'm going to find the model of the class, and all I do there is say, get the container object for the class, which is the model, and cast it to a model. So I'm going to get that model and just find his path. So whatever the path to that was, use that. So it's going to be the package. Let me bring up the other guy so you can actually see what I'm talking about. Here we go. So here's a sample here. So I'm going to look inside the model, which is this whole thing, and this is listed as PKG. So if I took a look at the grammar, we see package and then PKG equals that qualified ID. So I'm going to find from the class what's his model. I just go up a level. And then I'm going to create a path from it by taking that package and changing all the dots into slashes. So that's going to give me a path on the file system to put in. Add in the name of my class.java. And then here's the code that I want. Now they have this nice little templating language here using these triple quotes. This is what the code's going to look like. Anything that's in these little double brackets are variables that get replaced or expressions that get replaced. So I'm going to say package, put in that package name without changing the dots to slashes. Public class, the name of it, and then for each of the fields, generate the field. So when I look at generating the field, here's what a basic field generation looks like. There's a field for it, there's a getter, and there's a setter. So we're going to generate this code, and we do the same type of thing for primitives. For lists, lists are a little more complicated. They have that unmodifiable thing that I was talking about before, the add and the remove method. Here's how to generate an enumeration. So he's going to generate that enumeration file. And when I run this, I get my IDE, and when I save this, it generates my code. Let's take a look at the generated code. So I'm going to go to source gen, auto 1. Let's see what let's look at the address first. Here's the generated address class. Looks pretty much identical to the one I wrote by hand, right? But that's all I had to write. Now imagine this when you have 50 model classes. And this was something, one of the projects I got on a few years ago, somebody else had been developing the model before I got there. And he was handling everything by hand. And so he had 50 model classes, some of which did things in a slightly different way than others. So they were inconsistent. And then he started getting new requirements from the sponsor. Oh, I want these model classes to be hooked into Hibernate. So we needed to throw in a bunch of annotations on everything. So he had 1,000 places to go and add in these annotations. And I told him, stop right there. We're going to generate the code. So I set up something similar to this, and then in the code generator, have it generate an annotation. And boom, everything was fixed, as opposed to having to go and add those things in all by hand. The person class, very similar, almost identical to what we did in the other one there. You know why it's almost identical? Because when I prepped this talk, I did the code generation part first, and then copied the code over to the manual one. But this is actually how I would have written it by hand anyway. So I mean, it ends up, being how I wanted it to be. Now, what if we wanted to take this? You'll notice it doesn't have the return type being person and return the this on this, right? So what if I wanted to change that? Let me put the person and the address side by side. I guess I'll put him over here. So we have, here's our DSL, here's our person, and here's our address. If I go over into my generator, and let's take a look at, for a basic field here, I want to tweak my setter here. So I'm going to say for the return type here, I want to get the class of that field that contains it and use the class's name. So I'm going to say here, field.eContainer, so I'm just going to get his containing object as class type dot name. So it's going to put the class name there. And then I can throw in here, return this. Now let's do the same thing in these other spots. So for the setter down here, I'll change that. For the adds and the removes, for the lists, I'll change it as well. Then I'm going to add in the return this. And we'll do the same thing here. I've saved this, and I happen to be running that nested Eclipse in debug mode. So when I change things, it hot swaps them. If you add a method or add a field, it'll say, sorry, I can't hot swap that. But if you change the contents of a method, hot swap works pretty well in Java. So when I go to this nested guy, watch what happens when I save my DSL now. Boom. So now in both those classes, I get all that code generated for me. And now these classes are kind of small, so it's not a huge difference. But again, imagine you had 50 classes you wanted to do this to. I did changes in what, like 8 lines in my code generator, and now I'm getting the appropriate type here and the return this on every one of these. So now the code that gets generated here, let me go to Auto 2. I'll see that the generated code down here, let me actually get some of these out of the way here so we can see what we're doing. My generated code has, whoops, did I save that guy? There we go. So the generated code has that return type and return this. And now I can use that same type of Fluent API that I couldn't do before. Kind of neat, huh? Now what's really awesome about this is that you can have this code generation do anything you want. It can generate code, it can generate XML, it can generate, I'm using it in Android to generate a whole bunch of layout files. Let me show you a little example of what some of that looks like. Come out of here. And my machine is about to take off. So I have a much more complex model here, which I happen to be in the middle of editing. Oh, I'm not going to be able to show you the actual generation of it. But let me go into the nested Eclipse, and I can just show you what the little language looks like. So here's an example of a much more complex domain-specific language that I'm going to use to do much more code generation. You'll notice that these class definitions look kind of similar to what I just did there. Class something. I added in the idea of having superclasses. And then fields. So the fields are almost identical to what we just saw. I have a little bit of extra information up here that lets me have some dependencies. It lets me say the application name for generating some Android code. Any specific folder I can put my generated code inside of. I have some enumerations here, which we'll see have my display names in parentheses here. So this is something I could actually hand off to one of the people I work with who defines this data, and he could enter this for me pretty easily. And I tell him, don't touch anything else. Just stay there. You touch anything else, you die. And then down here, I can define my forms that I'm going to generate in Android. So each of these is going to define what's going on the screen. So I can have a little form for an air collection instrument that's going to have a little table of name and the value, manufacturer the value, flow and the value. And I have these little expressions to say how to get the data out of the model. This in turn generates the XML in Android, which has data binding expressions that use this type of syntax here. And let's see, anything else interesting down here? You can see this file gets kind of big, kind of fast. I need to break it up so that I can have separate includes and things like that, which I don't currently support. Then I define my top-level activities that are going to be used in Android, which forms they use. Those forms can include other forms. They can create a nice form there. And when you select something from the tree to say, hey, here's a plan I want to work on, boom, the form comes up with all the data populated. Lots of stuff is generated from this guy right here. If I went into my code generator, you see I have several code generation files here. I have something to generate the activity classes, to generate the models, to generate the binding adapters, which say how I convert data from my model into the things that are going to be displayed in Android. Enumerations, factories for these guys so you can create instances of all the classes. The form information there, and then some basic support at the top level to actually create my Java classes for me. So through this code that I've developed here, it generates tens of thousands of lines for me that I don't have to maintain by hand. And this has been nice because the customer is constantly asking for changes. And sometimes I'll need to tweak the DSL. Sometimes I'll tweak the code generator. Other times I'll just be messing with the code itself. But this saves me from having to deal with the model, which is a huge, huge benefit, especially when I think there's about 60 classes in that model right now. So it becomes quite a bear to maintain. Okay, any questions on that? So those are a few things you can take into account. Be careful with code generation. Don't look at it as a golden hammer. I mean, every once in a while, I'll do one of these talks and somebody will hear something and say, wow, that's cool. And they try to force it on everything. This is a great tool if you have redundant code somewhere. So if you want to try to, the same kind of pattern, not necessarily the exact code, but the same pattern over and over again. Code generation is a fantastic help on things like that. But sometimes people will say, oh, I can just generate everything, and they create this DSL, which some of the stuff in the DSL would have been easier just to code by hand. So be careful on things like that. Try to use it for something that you're going to go from terse to big when it's generated. Okay, make sense? And that is pretty much all I had for today. Any questions? And Eclipse, by the way, is better than NetBeans. I heard you guys talking about NetBeans back there. I've actually been using Eclipse since I used to use Visual Age for Java, and back in the late 90s. And then IBM killed that just after I wrote my book on it. I want to strangle somebody. It's like 6 months after the book comes out, boom, no more tool, no more book sales. And then they came out with Eclipse. And so I got used to Eclipse. Yes.
Without going into too many specifics, why do you say Eclipse is better than NetBeans?
Wow. Now, let me caveat that with this. I haven't used NetBeans in about 10 years. I have heard it's gotten better than that. Typically, I use IntelliJ and Eclipse. And IntelliJ I could speak to a lot more on that. The biggest thing that I like about Eclipse over any other environment I've seen is the way they do incremental compilation. So when I'm in here and let me switch back to the other workspace there. And it's taking off. So if I came into this guy here and I make a change to my item, like let's say I wanted to change the name of this method. As soon as I save it, everything else that depends on it gets compiled for me. I don't have to do a separate build, and it's really fast. In IntelliJ, for example, if I want to see that type of thing happen, inside the current file, it'll show you bugs as you're editing. But when you, unless you do a build, you won't see how it affects other files. And the builds take a while. So a lot of it is development speed. I mean, since I've been using Eclipse, it's just so fast to do things. Unfortunately, Google switched from Eclipse for its Android development to IntelliJ. And the equivalent support for doing Android development is just not in Eclipse anymore. So I had to move over. And I'm cursing it pretty much every day. It's really just, I mean, the way I'm doing my development right now, you notice that I just showed you that DSL for the project I'm working on. I do the model development in Eclipse. It generates code into some directories, and then in IntelliJ, he uses those directories as source. So I actually have both IDEs up and running at the same time, which is not terribly pleasant, but the support for Xtext just isn't there in IntelliJ yet. They're working on it, though. Yes?
Okay, so I actually have a question about code generation.
Mm-hmm. Sure.
IDEs. So with the game example and with the beans example, those are pretty trivial,
mm-hmm.
right? But a lot of times we want to generate code that we ourselves are using that's non-trivial. Like
mm-hmm.
We're generating code that invokes some kind of behavior beyond it.
Right.
So I've, that first part, generating the code that doesn't change
mm-hmm.
is pretty easy. But you get into this ugly situation where, I want to generate some boilerplate so I can insert those behaviors, but then I can't generate the boilerplate anymore. I'm kind of stuck with it. And if I want
okay, I see where your question's going.
I'm stuck going in and sort of making some manual changes, which is really ugly.
So
do you have a solution for that?
Yes. There are actually several solutions to that. So the question, to kind of boil it down, is sometimes I want to tweak what the generated code looks like. That's kind of what it boils down to. You need to do some extra customization because maybe the code generation itself isn't, you can't do everything you want in the code generation, or you want to do something special. One thing you could do, and this I do not recommend, is enhance the DSL to have much more complexity to it so you can do anything you want in it. And that's generally a bad idea.
I didn't do that.
Right. There are some ways in Xtext. There's an embedded language they call Xbase, which is basically all the stuff that's in extend with lambdas. It's Java syntax type things like that. You can just include in your grammar. So you could say, in your DSL, well, let me just throw in a, oh, did I switch the wrong workspace? Yeah, I did. Let me come back in here. Come on. Okay. And we'll run the nested guy here. So one thing that you could do is add in some syntax to say method, and then this would be Xbase stuff inside here, right, which can then generate Java code. So that's one thing you could do. I don't recommend that because you still want that extra flexibility. So there's a couple approaches you can use that are basically design pattern approaches. One of them is called the generation gap pattern. And what you do is you're going to be generating a subclass. And then you as you generate either a subclass or a superclass. It's up to you which one you want to generate. And then as a programmer, you come in and you insert either the superclass or you insert the subclass. And let's see, do I have a good example of that one? Trying to think of, I do have it in that other. Let me switch back over to this other one again. So one of the things that I did with this project, the new Untitled, is I have a little hierarchy that looks something kind of like activity, which that's from Android. Underneath that, I have a class called base activity, which is handwritten. And then as subclasses of base activity, for each activity defined in that file, I might have collection activity, planning activity, and a couple other things. And the code generator generates something called collection activity base. So that's generated. And then I come in and create a subclass of that called collection activity, which extends it. Now, what this does for me is you'll notice that there's handwritten stuff in two spots in this hierarchy, one at this top level and then one at this lower level. This lets me define methods up here and fields up here that this guy can use, all the generated code can use. This one lets me extend the generated code to add additional functionality, call methods inside of it. This is a really, really popular way to take care of generated code and allow you to have customizations. And you can keep customizing this and never touch your code generator. And this has proved just fantastic for me. Now, I actually extend it a little bit more than this with another generated thing in here. I'm just going to call it methods. How do I want to word this? I'm going to call it iMethods. It's an interface that gets generated. This guy let me show you what it looks like in the file. One of the problems I had is that I didn't want to be restricted by what code I could reference inside my DSL, but I wanted to keep it simple. So I have a list of methods that I define, which are basically just the method declarations, not the method definitions. And so these generate an interface, which is this iMethods guy. And then I have I'll just call it a methods def class, which is a handwritten guy that implements him. So having this guy and this guy implement him, I'm ensured that the definitions in here, the declarations in here match the definitions in methods def. So I can't have those two out of sync. And then this guy here, through a lot of the code that's generated for these expressions, uses those methods. You can call those methods. So by putting different hooks at different places in your class hierarchy, you can accomplish a lot of that. Now, it doesn't solve everything. One of the other problems that I had was that in some pieces of code, you want to have something that's generated be able to be used in multiple places. That's when you start looking at the strategy pattern. And so what you can do in your generated code, let's say I have a foo class that's generated. Inside there, have it generate an interface. So call it it might be a good updater. And he might have an update method. And then somewhere, and he has a set updater method that takes that updater. And where you're going to use it, you could say, something x, and do an x dot add new foo dot set updater new updater with the update method defined inside of it. This is just real rough pseudo-y code type thing there. But the idea here is that this guy, and this extra functionality that I wanted to run for the update, I'm letting somebody else pass it into me. And so that way, a little hole where normally I would have had to have something in the model that lets you specify random code, I can instead have a little interface that says, here's where the random code goes. And you just plug that in with whatever code you want to use. So these are a few really common techniques that people will use to be able to modify the effect of the generated code. I don't want to say modify the generated code because I have a very strong opinion that generated code should never be modified. Yeah. There are some tools. Trying to remember which tool it was. There were some GUI generators for Eclipse when Eclipse came out fairly early that you could put in, you take the generated code and you could add in some special comments that said, my code starts here, and then put in your code, and then my code ends here. And it would do a merge activity on it. So it would generate new code, take a look at the old code, and merge your special blocks back in. I think that's just gross. And that's something where this type of approach I think works a lot better because it's a lot more explicit what's happening. And if something changes in the code generator, you don't have to worry about it. With that Eclipse version there, if someone decided, we're going to, now that I have this ability for the user to put in blocks, I have to keep supporting that forever. And as opposed to something like this, it's like, you can just throw in code wherever you want it to that way. So does that help answer your question there?
A little bit. I'm going to go back and review this. Yeah, a little bit. I'm going to go back and review your video. I have another follow-up question.
Sure.
So you seem to be very focused on Java and Java tools. How many of these tools work with other languages, if any?
Okay, so the question is how many of these tools work with non-Java languages? The nice thing about code generation is that code generation doesn't care what the target is. You can generate XML, you can generate Java, you can generate Groovy, Haskell, whatever.
Well, right now I'm using Python to generate C++. So.
Okay, well, you could generate C++, or you could generate Python that generates C++, whatever you want to do there. The code generator itself, I really like this set of tools using Xtext, and that's all Java-based. So if you wrote that in Java with the, is this the right guy here? Yeah. With these extend classes, which are kind of like a Java++ for doing your code generation. In this particular case, you'll see that for my code implementation, I'm returning little objects that represent pieces of the code so that later on I can put them wherever I want to put them. You could use Java to do your code generation and have it generate C++, whatever you wanted to behind the scenes. And then that works just fantastically. So it's like I've in this Eclipse, in this Android project, it's generating the layout files, it's generating Android code, Android Java code. There's a couple other things it was generating. What was it? I had it generating a manifest file, which is XML. So you can have it doing any type of thing you want from the code generation. And that's something I like better than a lot of framework type code, because frameworks generally you have to have the exact same code in every different language. Although sometimes that's useful if you have your code generation. Well, that's another thing. You could actually have your code generator targeting multiple languages. So you could have it generate Java, you could have it generate C++, and the code's going to obviously be different from both, but it could be very similar, at least the style of it, the pattern that's being implemented. So, but yeah, Java right now is my main focus. Okay, any other questions?
Will your code examples be available?
Yes. So the question is, will the code examples be available? And I'm going to post those at JavaDude. So what you're going to see is at javadude.com. Boy, I have to really work on this website. This is so 90s. If we go to articles, it's microscopic too. I'm going to put in a new one up here that talks about this tech talk. And what these will do is these will jump off to where the videos are hosted. I will probably put this on Vimeo. So I'll have a link to the Vimeo place, and any type of sample code for each of those will appear there as well. And you can see I have a bunch of other videos here, things I've done as tech talks or tutorials. I try to put them up here as much as I can. So think of javadude.com as kind of an index for where I have my other stuff. Okay, any other questions? Thank you for asking those questions, by the way, about the different types of code generation things. Because yes, sometimes people will come to a talk like this and it feels like, everything, it's always just trivial stuff. But yeah, I mean, that's huge. I mean, being able to inject your own code in different parts of a hierarchy is probably one of the best ways to do it. Between that and the strategies, that covers probably 90% of your code customization right there. Okay, any other questions? I think the timing worked out pretty well on that. Yay, just about an hour. Did you have any wrap-up?
So thank you very much for the talk this evening. The Tech Talk series has been running for 2 or 3 years now. We are always looking for speakers as well as additional topics. So if any of you have suggestions for future Tech Talks, please send them to Ellen or Clan, and we will make sure to try to get those scheduled. The next Tech Talk will be focusing on data science and is expected to run sometime in the October timeframe. So thank you all for joining us and have a great evening.
Cool, thanks a lot.